Right, welcome back, folks. This is the second part of our algebraic fractions, equations, and expressions. Please remember to subscribe to the channel, hit like button, share, so that you can help the channel grow and also receive notifications when new releasings are done. Without further ado, let's dive into 10 more classwork questions similar to the ones that we've covered before. The first problem here, we are interested in the LCM of 2x and 4x. So like we did earlier on, we start by targeting the coefficients 2 and 4. So LCM there is going to be 4. Then for x and x, the variables, we take the smaller degree. Now the degree is the exponent. So if we check for both parts, it's 1 and 1. So actually our LCM is going to be 4x. Then next we want to simplify 6y over 12y. Obviously we can start with the variables. Y on the numerator, y on the denominator, they cancel out. Now 6 over 12 in simplest form is actually 1 over 2. Still moving, we have got fractions that we want to add. And when we check, our denominator is the same, so it becomes our common denominator or LCM. So we simply simplify the numerators, which are 3 plus 4, it gives us a 7. Still moving to the fourth problem, here we are subtracting, and the scenario is similar to the previous one, where we are saying if we check our denominators, it's a and a, and because it's the same, it becomes our common denominator or LCM. So we simply simplify the numerators, which are 7 minus 2, giving us a 5. Then moving on, this time around we have a slightly different problem where our denominators, one is x, the other one is 3x. But if I look at x, the coefficient is a 1. So LCM of 1 and 3 gives us 3. And LCM of x and x is actually x. So the common denominator is 3x. Now, what do I do? I divide 3x by x, it gives me 3 times the 1 on the numerator, I have 3, plus, there's a plus sign there. 3x divided by 3x, that's 1 times 1, there we have 1. So the last step is we can simplify the numerators. 3 plus 1, it gives us 4 over 3x. That's our final solution there. The next problem, we are asked to give a definition of an equation. So an equation is, can define it as a balance between algebraic expressions. So when I say balance, it means the equal sign is appearing somewhere. So it balances the left and right hand side. Identify the unknown and the equation 4m plus 6 equal to 22. At least 6 and 22, they are known, but m there is an unknown. So m becomes the unknown. Then number 8, we want to solve an equation where we have x plus 9 equal to 15. If we want, we can use the change sign rule, where we are saying, can we transpose the 9 so that it combines with 15. So I'll end up having x here. The other side, it will be 15. But remember, when we transpose a value, or if a value crosses the equal sign, its sign also changes. It was plus 9, it becomes negative 9. Then our x will be 15 minus 9, which I believe gives us a 6. Then moving on to number 9, we're interested in solving 2x equal to 14. So we want to get rid of the 2 there. So we're going to use the reverse method, where we are saying to get rid of a value, if it's multiplying, we divide. And we divide by the value itself, which is 2. But because of the balance, whatever we do to the one side, we also do it the other side. So if we divided left by 2, we must also divide right by 2. But in the process, we have 2 on the numerator, 2 on the denominator, they cancel, leading us to x. Then the other side is 14 divided by 2, giving us a 7. Then next one, we are interested in stating one real life example where equations are used. Well, equations, they are used in uh, lots of scenarios. For instance, if we want to do mass conversions, for instance, if I want a mass in kilograms from tons, we can build an equation to say, well, kilograms is equal to 1 times whichever, I mean, it's 1,000 times whichever quantity of tons that will be having. So it will be 1,000 times the tons. That's how we find the quantity of kilograms given tons, such that if I've got 2 tons, it means in kilograms it's going to be 2,000. So it's quite a lot. Sometimes we use equations when we are plotting graphs. One other example can be y being equal to 2x plus 4. In order for us to get the value of y, we need the value of x, or to get the value of x, we need the value of y. So it brings in a relation between the left-hand side and the right-hand side of two given expressions. I think that's it for the second series. And remember, folks, to subscribe to the channel so that you can receive updates as long as new editions are done. Bye for now.